Power. Power is the rate at which work is done on an object. And as you take more physics, you'll learn anytime they talk about the rate, means you're dividing by time. Velocity is the rate at which distance is changing its distance over time. Acceleration is the rate at which velocity is changing its change in velocity over time. Power, symbol capital P, lowercase p, momentum, uppercase P, power, is work over time. Back to the paragraph above. If you are exercising and you're getting tired, it's not because you're doing work. It's because you're generating lots of power. Power causes tiredness. Cole, when you talk to a basketball coach and you're panting, "Coach, I'm working hard," you should say, "Coach, I'm powering hard. I'm generating lots of power." What would the units be? What are the units for work? What are the units for time? So power is measured in joules per second, but power is such an important concept, we give it a name. Power is measured in what? Symbol capital W. And if you don't think this gets confusing, because what's a capital W as a variable? Work. This W here is not watts, it's work. But a W in my answer is watts. Unless there's an at symbol in front of it, then it's west. And there's even a lowercase w that means angular velocity, which you won't look at in Physics 12. I've gone on my rant that we're running out of letters. We are! Every once in a while we'll even bring in some Greek letters, and that's not enough. So power is measured in what? Boy, what can I do to get your attention? Power is also a scalar. It has no direction, much like your futures. Suppose an electric motor is used with a pulley and rope to lift a 650 Newton load from the road up to a height of 12 meters. Do me a favor, underline the word lift. That tells us something. This job is done in a time of 11 seconds. What's the power output of the motor? What does this question want me to find? Power. Power is going to be work over time. Work is measured in joules. Do I see joules anywhere in this question? Rihanna shakes her head. Oh, what was work? Work was what times what? It's on your sheet from last lesson. Okay. So it's going to be force times distance over time. And then I said to you last day, the reason I underlined the word lift, when we're lifting, how big is the force that we're lifting have to be? The same size as mg. I know mg is down and lifting is up, but I'm arguing, in fact, I think it was Hannah that I picked on last time. I said, Hannah, if you imagine the free body diagram, we'd have gravity down and lifting force up, and as long as we're going at a constant speed, they are the same magnitude. So this is why I was able to say when you're lifting, the work was mg, and then we called it h. I'm not actually saying that the force is gravity. I'm saying it's the same size as, because the force and the distance did have to be in the same direction. Over time. Dylan, did they give me a time? And it's the correct units. Did they give me an h, a height? And that's the correct units. Did they give me a mass? 650 times 9.8? No. Wait a minute. This right here in newtons is weight. No, now. This right here is mg. We said that mass is measured in what units? What do we measure mass in? Kilograms. Weight is measured in newtons. And once in a while, during this year, I have occasionally skipped the mass and just given you the weight. In other words, Dylan, I'm going to say I can put that 650 in for the mg, because that's what weight is. I think I even included that on your formula sheet in the forces unit. Doesn't it say something like weight equals mg, force of gravity, or something like that? How many watts of power are we getting out of this motor? What'd you get? 709? Is that right? 0.9. So it wouldn't 710 if we round it up? No, 7.709.09 or 7.9? 709.9. You lost me.
I'm right. Okay, I did.
Oh, I'm sure you are, because it has to happen eventually.
$5.
So, would I round that to 710? I would round that to 709.1. So you're wrong, 710 boy.
No,
So let's just go. I agree. Your first answer was correct. And Christian, power is measured in watt? By the way, what if we wanted to move this faster? What if time got smaller? Since it's on the bottom of a fraction, if this number gets smaller, what happens to this answer? Bigger, smaller, or stays the same? You're right. Bigger. In other words, you want the job done faster? You need a bigger motor. You need a motor with more power. Okay. The watt is the metric SI unit for power. In the American imperial system, which only 2 countries on the planet now use, the unit of power is the horsepower. What a stupid unit. Do any of you know how much work a horse is capable of doing in an hour? Anybody you'd have to have a fair bit of experience with horses to know that, and yet they're still using that unit. Oh, this car's got 150 horsepower. I guess that means it does the work of 150 horses. That tells me nothing. Okay. So I'm imagining a herd of horses pulling a big what? 1 horsepower is around 750 watts. I think it's 751 point something, something, something. And you don't need to memorize this. If I'm asking you to convert watts to horsepower or horsepower to watts, I will give you the conversion factor on a test or in a quiz. So the motor in this example would have a horsepower, how much? Convert 709 watts to horsepower. Oh, if I'm converting something, what was the first thing that I always did as my no-brainer just to start out? It's getting towards the end of the year, so we're viewing some of this. What would I do if I wanted to convert 709 watts to horsepower? What did I say I did as the first step always? Sierra. I'm going to write down what they gave me. 709 watts. Not 709 west. I want watts to cancel, don't I? So Sierra, in this next fraction, where am I going to put watts? On the top? Oh, on the bottom, you say. Oh, so I don't need to figure out whether or not I'm dividing or times. The units tell me, you say. So I put watts there, and I'll put HP for horsepower there. And what's the conversion factor? How many horsepower is how many watts? So I guess a 1's going to go there. And so where is that 750? On the top or on the bottom? So am I going to times or divide? I don't memorize whether I multiply or divide. I build the chain, and it tells me. I got better things to save my brain for. I think you're going to find this is almost but not quite 1 horsepower is like 0.9. You know what? Christian, why don't you, this is a chance for you to, and I'm going to use my answer button because I got the 7.0909 still on there. Do you get 0.95 of a horsepower? Okay. This gives me something to hang my hat on. That's almost 1 horsepower. So I guess when they're talking about horsepower from now on, I imagine lifting a 650 Newton load. That's roughly 65 kilograms. That's roughly a person, an adult. 12 meters, 3 stories, 4 stories in 11 seconds. Okay, I can imagine that. 1 horsepower, I'm imagining a person in a harness kicking and screaming on a pulley. The horse starts to gallop away. The person and gets lifted about 3.5 stories in a 10 count. 11 seconds. In a 10 count, roughly. Okay, I got something now. That I don't know what a horse can do. A girl runs up a flight of stairs, 3.32 meters high. That's bang on this one behind me here, plus or minus a couple of centimeters, in 2.6 seconds. If you ran those stairs in 2.6 seconds, is that fast or slow? Would you be walking or would you be huffing a little bit here? You've all walked that set of stairs at least once. So 2.6 seconds. Are you walking it? No, I think you're... Are you sprinting it? No, I think you're quick stepping it. Maybe you're going the steps 2 at a time just because you can at a jog, but you're not like going full out. Okay. Cool. Mateo, not Mateo. Mateo, what's this question want me to find? Part A? Well, power is going to be work over time. Work is what times what? Cool. I can see the time. I think this is a distance. Oh, when you climb stairs, which force are you doing work against? What's the equivalent force that you have to apply upwards? In fact, you might notice I get exactly the same equation as the previous question, mgh over time. Mateo, what's m? G, 9.8. Negative? No, we're in scalarville now, so we don't need to worry about the negative. Distance, 3.32. Time, 2.6. How many watts of power will this generate? Yeah, 751? Power is measured in watt. If 1 horsepower equals 750 watts, what's her power output? This is my other one. This is almost exactly 1 horsepower. If I'm trying to think of how much power 1 horsepower is, I imagine a medium-sized person quick stepping up the flight of stairs behind me over my shoulder. That's about a horsepower. There, now I've got my hook. 'Cause I don't know what a horse can do. And by the way, the horsepower has nothing to do with horses. What? The horsepower was originally invented by James Watt, of whom the watt is named. And I have to be honest, this is one scientist who, in my mind, is overrated. Often people say, well, he invented the steam engine in Britain. He didn't. He improved the steam engine. What he really was a terrific salesman. So I'd like you to imagine 300, 400 years ago, you're trying to sell the steam engine to farmers, and you're trying to say to them, it's capable of doing work, and you want to put it somehow into terms that they will understand. He invented the unit, the horsepower. It's pretty arbitrary, but when he told a farmer that this motor has 5 horsepower, what does the farmer think? This will do the work of 5 horse. Now you got your sale, because now the farmer is saying, so I can get rid of 5 horses. I know how much hay I can lift each day with those 5 horses, and how many fields I can. You got yourself a deal. And in fact, it was such a brilliant sales job that even now the horsepower is one of the standard units of measuring power. Even though none of us have ridden, most of us have not ridden a horse, don't hang around, we've nothing to do with horses. So I should point out that 1 horsepower is not the amount of work that 1 horse can do in 1 second, which is what it should be technically. Example 3. Nick, what's example 3 asking me to find?
Time.
Ooh, you know what? Let's go back to our little DFIC approach. Let's go T equals, because I've never found time before, so let's hedge my bets and be more careful. What's that 10? I don't like that unit. It's power, but it's in the wrong units. So let's write down P equals 10 HP, but let's do a conversion. Nick, I want horsepower to cancel. Where is it going to go in my fraction? Oh! So then where is watts going to go? And the conversion factor, it says 1 horsepower is the same as 750 watts. That 750 is on the top, so am I going to divide it or times it?
Divide.
That 750 is on the top, so I'm going to times it or divide it. As opposed to on the previous page when the 750 was on the bottom and we divided it. Is that okay? In your head, without a calculator, put your phone away. Without a calculator, 750 times 10. Just add a 0. Okay. What's that 500? And its units are fine. I checked kilograms. What's that 30? Although, Nick, do me a favor. Underline the word lift. When we've been lifting, what variable have I been using for that distance? I haven't been using a D. What have I been choosing to use instead? Height. If you said D, I'd give you full marks. But Nick, do you mind? I'm going to call it H equals. What are we trying to find?
Time.
Well, the only equation that has time in it is power is work over time. What do I want to get by itself then?
Time.
Which is which variable here? Where is the T right now? On the? Ugh. Wait. Look up. Dividing by T on the right, isn't that exactly the same as timesing by T on the left? Because that's how you would have moved it over. Yes? How would I get the T by itself? What's the P doing to the T? Adding, subtracting, multiplying, or dividing. So how do I move the P over? Yeah, you just got to be careful. A lot of kids go T equals P over W. No, it's W over P. Power is measured in watts. That's where the 7,500 is going to go. W, work. And again, I know, Cole, it's confusing because watts is W and it's tempting to want to put the W into the W. Please don't. Sorry. Nick, work was what times what? And then we took that when we were lifting, we actually said when you're lifting something, you can modify that force times distance into what? Look up. Force times distance, mgh. Not over T, just mg. In other words, when you want to find out how much work you're doing against gravity, mgh. Is that okay, kiddo? So, we're going to have mgh over P. Mass is 500. G is 9.8. H is 30. P is 7,500. Now, this question here is kind of interesting, but take this same and instead, you're the Port of Vancouver. You know how strong your cranes are, what their horsepower, what their wattage is. You know how many kilograms of ships you need to unload. You know how high you have to lift them. How long will it take me to unload the ship? Now that's a much more useful calculation. You can start to plan out what your minimum time has to be. And you can't go any faster. If you want to go faster, you need power to get bigger. You need a bigger crane. What do you get? 19.6 even? And seconds would be the units because we did our correct units. What if I want to do this in 15 seconds? It's impossible. I need a stronger motor. Because P on the bottom would have to be bigger to make this answer smaller. What if I got more than 19.6 seconds? You can use the same motor and just not run it full out. Power can also be measured in kilowatts, kW, or megawatts. Did I give you the kilo and the mega prefixes on your green sheet? Yes? So you might have them memorized. I know kilo is 1,000 and I know mega is 1,000,000 because it comes in computer memory that way too. But do you need to have them memorized? They're on your sheet. How much are we doing here? A couple more? Yeah, we're good. Power of a light bulb is the amount of energy it uses in 1 second. So a 40-watt bulb uses 40 joules per second. An 80-watt bulbs, who has those? A 60-watt bulb, fairly common bulb, uses 60 joules per second. 100-watt bulb uses 100 joules per second. What's the power rating of a bulb that uses 4,200 joules in 70 seconds? See, how are you going to make it? Those are long blinks. Okay? Christy, what's this question? What's example 4 asking me to find my angel? Yes, with authority and confidence in your voice, please. Power! Okay. Well, let's write down our power equation. Christy, did they give me a time? How much? Oh, hey, let's stick that in. What are the units for work? Christy, my angel. Did they give me joules? Oh! You mean it's just going to be that? Yeah. What kind of light bulb is this? Is it a bright bulb or a dim bulb? My mom says I'm not the brightest. Nicole, she means something different. What was that? Sorry? 60-watt bulb? Yeah. And that's what the different wattages mean. That's also why, by the way, a 100-watt bulb, it's brighter because it's using more energy per second. The energy's got to go somewhere. It's also why a 40-watt bulb doesn't get as hot to the touch as a 100-watt bulb. Because a 100-watt bulb is using that energy up faster, and part of that energy is spun off into heat. A microwave is rated at 1.2 kilowatts of power. Usually there's 2 types of microwaves, the small ones and the bigger ones. The smaller ones are usually around 800 watts. The bigger ones are usually around 1,200, 1,400 watts. So this one's 1,200 watts, 1.2 kilowatts. How many joules of energy does it use? Tristan, what's this question asking me to find? What do I measure in joules? No. Which is? Oh. Okay. Let's write down our power equation. But, Tristan, how would I get work by itself? What's the T doing to the W? Adding, subtracting, multiplying, or dividing? So how do I move it over? Are you telling me another way to calculate work? Now, I already told you that work was force times distance. But if you don't have a force or a distance, it's also power times time. Do a quick check. Did this question give me power in the question? Did it give me time? The units are lousy, though, so we have to do some unit fixing. 1.2 kilowatts. How many watts is that? How do I go from kilo to regular? Anybody know? This times by 1,000. So this is going to be 1,200. Tristan, do I do physics time in minutes? What's our preferred unit? How do I go from minutes to seconds? It's got something to do with a 60. Times, or is it divide? 1 minute is how many seconds? 2 minutes is how many seconds? How would you turn a 2 into a 120? Would you go 2 divided by 60 or 2 times 60? Oh, so how do I turn a 6 into seconds? 6. And I'm glad Tristan did that little dance with me. That's how I figure out most of this. I've never bothered memorizing, do you times or do you divide? I make up an easier number that I know the answer to and say, well, how would I get that answer? It's got to work for the one I don't know the answer to. What'd you get? By now you've rushed off to your calculator, eager, with your eyes ablazing, desperate to know what the answer is. Right? Right. What'd you get? Read me the digits. 4, 3. 4, 3, a 2, and how many zeros? 3 zeros. Is that correct, folks? People nodding? And this is work. What were the units for work? This is how you get your electric bill. You don't pay for power, you pay for energy. The only problem is a joule is so small, that's running a microwave for only 6 minutes. Can you imagine if you got your bill in joules at the end of the month, it would be in the billions or in the trillions of joules and people would freak out. So there's another way to measure energy. It's called the kilowatt hour. Everybody underline that right there. Tristan, can you do me a favor? Can you read to me this equation right here? Work or energy is equal to, say it again. Not to make fun of you for a reason. Say it again. Stop. There's power. Times. Stop. There's time. Not our preferred units, but that is power times time in disguise. It's just not the units that we want. But if any of you, once you move out, once you start paying your BC Hydro bill, you're going to see they bill you per kilowatt hour, not per joule. Joule's too small. 1 kilowatt hour, well, a kilowatt is 1,000, an hour is 3,600, so 1 kilowatt hour is 3.6 times 10 to the 6 joules. Sierra, you don't need to memorize that. You're doing some long blinks there. I will give it to you if I ask it to you on a test. So, how many kilowatt hours does this microwave use? Tristan, this wants me to convert 432,000 joules to kilowatt hours. What's the first thing I'm going to do? What's the first thing I always do when I convert something? Oh, heck yeah. 4, 3, 2, 3 zeros, and that's in joules. Tristan, my friend, I want joules to cancel. Where's the J going to go in my next fraction then? Oh, heck yeah. Where, Nick? On the bottom. Oh, heck yeah. And I want kilowatt hours on the top. Here's my conversion factor right here. I guess 1 kilowatt hour is the same as 3.6 times 10 to the 6th joules. Tristan, that 3.6 times 10 to the 6th. No, Nick, that 3.6 times 10 to the 6th. Is it on the top or is it on the bottom? So am I going to multiply or am I going to divide? So on my calculator, hopefully you can just use your answer button, folks. I'll have to type this from scratch. 4, 3, 2, and 3 zeros divided by 3.6. Ooh, where's that scientific notation button? Right there for me. Please try typing that in just so that you can double check that you remember how to do scientific notation. By the way, we have 17, including today, 17 classes left. No!
Oh, yeah.
No!
Oh, yeah.
Aww! Oh, I don't want this to end. You get 0.12? Kilowatt hour. If you did not get 0.12, if you got a 1 and a 2 and more zeros, you didn't use your scientific notation button, you hit times, and then you hit 10 to the, so you got to put the bottom in brackets, or you got to learn your scientific notation button. Good stretch? Good. Put your pencils down, look up. You may have tried to nuke something in the microwave, and you may have read the package instructions and it tells you how long to put the microwave oven on for. Here's how they calculate the time. Suppose a hot dog takes 40,000 joules of energy to cook. If a microwave is rated for 800 watts, how long will it take to cook a hot dog? Huh. Brian, what's this question asked me to find? Time? And they gave me, what's this joules a measure of, Brian? Not watts. No, power is measured in watts. That's power right there. What's the joules a measure of? Work. Is there an equation that has power and work and time in it?
Work equals
Is there an equation that has power and work
power
and
equals work.
our starting equation? Yes? What's this question asked me to find? Okay. You know what? Let's write down the equation. You might be able to do this in your head. I don't know. How would I get the t by itself? Where's the t right now? Blech. Wait a minute. That's the same as this. And then how would I get the t by itself? So you're telling me that the time to cook the hot dog is the amount of energy divided by how fast you can send the energy, power. How much energy does it take? How many watts of power can this microwave put out? How many seconds are we going to have to cook this hot dog to cook it through? 50 seconds even? That's how they calculate the amount of time that's printed on the back of package instructions. There's a problem though. Microwaves typically come in two types. Small ones, about 800 watts. Large ones, about 1200 watts. This is also why on the back it always says microwave oven times may. You see, you've all seen that. What if you're using a bigger microwave? How long would it take? Well, it's going to be the same calculation. Time is going to be the amount of energy work divided by power, but now it's going to be 40,000 divided by 1200. How long will this microwave take to cook it? What'd you get? 33.3 repeating? And it's why it always says microwave oven times may vary. Oh. There's a special version of this equation, and it's when you're moving at a constant speed. Okay. Power is work over time. Write that down. David, work is what times what? This is from last day. Got a formula sheet. We've used it several times today too. So find on your formula sheet, work is what times what? Did you say force times distance? It's force times distance over time. You okay with that, Hannah? Now what I'd like you to do with your pen or pencil, circle those two. David, what do I measure distance in? What do I measure time in? So you're saying what I've circled is meters per second? Oh! What's meters per second a measure of? Technically, since we're in Scalarville, speed. But another equation for power is force times speed if you're moving at a constant speed. How do I know that I have to use this if it asks me how much power and it doesn't give me time, but it gives me a speed? For example, David, what's example 7a want me to find? First thing I would go with is I would say, okay, power is work over time. Do you see a time anywhere in this question, in seconds or hours or anything? There's another definition of power, and I think I did also put the second definition on your sheet. Did I not say, I hope I said power equals W over T, and did I also then say equals F times V? I didn't put that on there? Really? Well, I guess we'll just have to derive it. What did you say work was? Force times distance over time. What did you tell me distance over time was the same as? So you're telling me this is also force times speed? You might want to maybe write that down as a second definition of power on your formula sheet next to the first definition of power. Did they give me a force, David? Did they give me a constant speed?
Yep.
How do I know the speed is constant? Because if my force is constant, I'm exactly canceling out air resistance. So what's my net force? 0, which means what's my acceleration? If my forces are balanced, 0, which means I'm at a constant speed. Okay. It's going to be 32 times 12. You know what? I might be doing the lab, actually, now that I think about it, on Monday. I might have to do one more lesson. What'd you get?
384.
Power is measured in watt? About a half a horsepower, by the way. About a half a horsepower-ish. If you want to go faster, will that require more power or less power? Well, if this number gets bigger, what happens to this answer? How do you, because is this number on the top or on the bottom? It's on the top, so if this gets bigger, this gets, so if you want to go faster, you need, yep. From experience, when you're biking, does pedaling faster make you more tired or less tired? Because you're generating more power. And this is why I said at the very beginning, power is tiredness, not work. Okay? So coming full circle there. What's your homework? You can try number 1. Let's do number 4. I'll skip 2, and for some reason there is no 3. By the way, the time in number 4 is half an hour. How many minutes? How many seconds? Do the math. Yes? 6 is good. 7 is good. What's number 7 asking me to find? Power. Power is work over time. How much time in number 7? It's very subtle. How much time in number 7? Per what? It's 60 seconds. I was sneaky. I didn't say over 60 seconds. I said per minute. So T is going to be 60 seconds. Okay? A little sneaky minutes. 8 is good. 9 and 10. Part B asks in number 10 for efficiency. That's our next lesson. So if you don't know how to do Part B, I'll teach you.